Hi there, and welcome to today's video. We will be discussing the importance and need for breakwaters, common construction materials, and their overall effect on the environment.
This study attempts to analyze, identify, and select the materials to build an eco-friendly permeable breakwater system, where coastal erosion is an ongoing problem that has not been completely solved. Coastal erosion is the destructive force that causes the deterioration of land habitats and infrastructure. For the remainder of this video, in an attempt to understand how to stop this deterioration, we will establish what a breakwater is, how it functions, how different materials can be harmful, and why we do not want to further our study by researching harmful materials. By comparing three systems that are suitable for the study of sustainable materials that work within a breakwater system, this will allow us to preserve and help an existing coastline from deteriorating, while also creating a healthy environment for humans and wildlife in the area. To begin, we must analyze what a breakwater is and its main function. A breakwater system is a permanent structure constructed at a coastal area. These systems help to protect against tides, currents, waves, storm surge, and erosion of property to prevent damage along the shoreline. A breakwater's basic use is to protect the shoreline from strong wave action. It does this by lowering the tidal energy as it hits the structure and gets reflected off. Think of sunglasses for the sun or a windbreaker for a windy day. Compared to seaward seas, the water lying behind these breakwater structures are notably calmer and better protected from the tidal current. This provides an artificial shelter for the harbors, infrastructure, and vessels. Depending on the kind of protection region, breakwaters can be categorized as coastal protection or harbor protection structures, or both. As navigational aids, breakwaters make the seas calm enough to permit the safe use of harbor amenities and marine operations, used for boats to anchor and tie during rough seas. What is notable is that there are many advantages to these systems and the use of them. By establishing multiple forms of protection, a shoreline can undergo a drastic change once a breakwater are installed. After learning about what a breakwater is and how it functions, it is important to understand the different kinds of breakwaters that are evaluated in the study. This will allow us to determine how a different system may be more beneficial in different locations. Based on a large amount of research, we can determine what these systems are. Many fall within two types of systems: a rumble mound breakwaters, which are made up of large heaps of loose elements, or a monolithic breakwater, which have a cross section acting as one block, for instance, a caisson. Many factors will determine what type of breakwaters would work best after the architect and engineers collect data on the area about the waves, storm patterns, tides, to design and lay out the best system for the area and region.
Once the type of breakwater is chosen by the architect through formulas and prototyping, the material is to be decided next. This can be a difficult task for an architect within the 21st century, as many materials that are used for the construction of these systems are harmful to the environment. In order to establish a more suitable material that is eco-friendly, it is important to understand how all materials function within the breakwater system. The material that is used most often with this system is concrete. This is due to the effectiveness it has as a wave energy damper. The effectiveness of structure type to reduce wave energy is influenced by the geometric shape and configuration of the breakwater placement, as well as the water depth, height, and wave period. Due to concrete working well in these ways, it is used most often. The negative side effects to a concrete breakwater is deterioration over time. The structure begins to erode, thus leaving sediment and harmful chemicals within the water. The system that we would like to implement would not harm the environment, so concrete had been eliminated due to these observations. The next material that had been researched was bamboo, as the material is a fast-growing, renewable resource that can be utilized in tropical climates where many coastlines are deteriorating at a more frequent rate. Research shows that bamboo is stronger than steel, cheaper than many other materials, is a renewable resource, and allows to capture maximum sediment and minimize abrasion strength. The many advantages of this material helped us gauge what types of materials we should be utilizing and if there were any materials that are comparable to bamboo but for colder climate zones. The final material that had been studied was PVC piping, as it had the same shape as bamboo and came at a cheaper cost than concrete. The disadvantages of this material, though, was the limitation of coastal areas based on the wave strength having a large effect on this material. In areas where the coastal winds are strong and wavelengths are high, this material will not be sufficient. What was important about this material, though, was the ability to use recycled materials to construct this breakwater system, and also the advantage of easily replacing sections where the breakwater would begin to collapse.
In order to properly develop and understand the research we put forth, we have decided to discuss 3 viable sustainable options while keeping in mind their uses in varying climates. We would like to take a deeper look at tetrapots that could be utilized in cooler and warmer climates, PVC pipes for northern regions, and bamboo for southern regions. Tetrapots are a newer material that combine the beauty of mangroves with the stability of concrete. They utilize a protective shell made of materials that are non-detrimental to the surrounding environment. This shell is then filled with concrete to give the pot stability and has holes that allow the roots of the plants to extend out and create a water-level area of greenery that inhibits harsh waves to the shoreline. The video you are watching is an explanation of this process and highlights the product's features. Next, PVC pipes act as floating breakwaters and are attached to each other in nodes. This creates a breakwater that does not affect the shore bottom and provides easily replaceable sections if any damage were to occur. Although these are not as beautiful to the eye, there have been multiple studies done on the approach and already have studies on the depth that are needed to reach underwater in order for them to be effective barriers for our precious shorelines. Finally, bamboo is another option that applies the needed strength, sustainability, and beauty to the breakwater. With an exponential regrowing rate, a tensile strength higher than steel, and a natural material, this will only aid to the development of wildlife and is a great choice for a breakwater. Our goal is to establish a study that would show the success rate and upkeep over time of these 3 materials. The following videos show some examples of such small-scale models. We would want to focus time and energy on incorporating scaled models of the 3 options with small hydraulics to mimic the water pressure and wave strength of different climates and shorelines. Ideally, our study would be openly available to designers and the interested researcher alike so that our research would be used and considered when other locations begin divulging options for their own breakwaters. We hope that our model can also be easily replicable at a cost-efficient rate so that the user group can more effectively conduct additional research if needed. Thank you for taking the time to listen to our research and presentation. We hope you have enjoyed learning about the importance and effects of breakwaters.